Hello, this is Raghuveer Pandit. In today's session, we are going to discuss the example of slow frequency hopping spread spectrum from Module 5. The content is prepared from the textbook Fundamentals of Communication Systems by Prokis and Salehi. Slow FHSS system. If hopping rate RH is less than or equal to the symbol rate RS, the frequency hopping system is called as slow hopping system. Consider the problem statement. The FH bar MFSK signal has following parameters. The number of bits per MFSK signal, capital K is equal to 2. Number of MFSK tones, capital M is equal to 2 per capital K is equal to 4. Length of PN segment per hop, small k is equal to 2. Total number of frequency hops 2 power small k is equal to 4. Assume binary data sequence to be 0 1 1 1 0 0 1 1 1 1 0 1 1 0 0 0 0 0 0 1 and PN sequence be 0 0 1 1 0 1 1 0 0 0. Determine the following. A. Draw the variation of frequency of FH bar MFSK signal for given PN sequence. Assume that carrier hops for every 2 MFSK symbols. B. Sketch the variation of D-hopped frequency with time. Solution to this problem. Consider two first parameters. The number of bits per MFSK signal, capital K is equal to 2, and number of MFSK tones, capital M is equal to 4. Here we are going to construct one table for these two parameters. If we consider 2 bits of MFSK symbols, there will be 4 combinations that is given by 0 0 0 1 1 0 1 1. Corresponding MFSK frequency or MFSK tone in hertz will be F0, F1, F2, F3. Binary data sequence which is given in the problem, we need to group it into 2 bits as shown in the figure. So this table will be represented for our grouping representation for data sequence. Consider the third and fourth parameter. Length of PN segment per hop, small k is equal to 2, and total number of frequency hops, that is 2 power small k is equal to 4. Construct one table for these two parameters. So PN sequence segment small k is equal to 2. If we consider 2 bits now, we are having 4 combinations 0 0 0 1 1 0 1 1. For these bit combinations, corresponding hopping carrier frequency in hertz can be represented as FC0, FC1, FC2 and FC3. For the given PN sequence, group this PN sequence into bits of 2. So this table or this parameter 3 and 4 is for carrier frequency or PN sequence. Assume that carrier hops for every 2 MFSK symbols. Here input binary sequence and PN sequence we have written in the table. For 2 MFSK symbols, there is only one carrier hopping frequency we have represented. For 2 MFSK symbols 0 1 1 1, only one carrier hopping frequency is given, that is 0 0. Similarly for 0 0 and 1 1 MFSK symbol, we have represented only one carrier hopping frequency, that is 1 1. For MFSK symbols 1 1 and 0 1, we have represented only one carrier hopping frequency, that is 0 1. For MFSK symbols 1 0 and 0 0, we have represented the carrier hopping frequency as 1 0. And the last one, for two MFSK symbols 0 0 and 1 1, we have represented one carrier hopping frequency 0 0. This will be our x-axis or time axis. So write down the input binary sequence and PN sequence on the x-axis or time axis, and input binary sequence name the bit 0 0 as F0, 0 1 as F1, 1 0 as F2, and 1 1 1 1 as F3. Similarly, the PN sequence name 0 0 as FC0, 0 1 as FC1, 1 0 as FC2, and 1 1 as FC3. Next, we are going to write down the y-axis. On the y-axis, we are writing the carrier frequency. From the previous table, we are having total 4 carrier frequencies, that is FC0, FC1, FC2, FC3. Write these carrier frequency on the y-axis. And again, these FC0, FC1, FC2, and FC3 frequencies, we are divided into 4 sublevels because we are having 4 MFSK symbols or 4 MFSK frequencies, that is F0, F1, F2, and F3. So represent or divide the each carrier frequency into 4 sublevels, okay, and name the given frequency F0 as 0 0, F1 as 0 1, F2 as 1 0, and F3 as 1 1 for each carrier frequency, that is FC0, FC1, FC2, and FC3. Now we have to mark the representation for given binary and PN sequence. So in the first instance, the given binary data sequence is 0 1 and PN sequence is 0 0. So in FC0, mark the F1 frequency. In the second instant, we are having binary bit as 1 1 and PN sequence as 0 0. In the sense, in the FC0, mark the 1 1 frequency. In the third instant, we are having 0 0 as input binary sequence and 1 1 as PN sequence. So in this, in FC3, mark the F0 frequency. In the fourth instant, we are having 1 1 as input binary sequence and 1 1 as PN sequence. In FC3, mark the F3 frequency. In the fifth instant, we are having 1 1 as input sequence, input binary sequence, and 0 1 as PN sequence. In FC1, mark the F3 frequency. And in the sixth instant, we are having 0 1 as input binary sequence and 0 1 as PN sequence. So in FC1, mark the F1 frequency. In the seventh instant, we are having 1 0 as input binary sequence and 1 0 as PN sequence. In FC2, mark the F2 frequency. In the eighth instant, we are having 0 0 as input binary sequence and 1 0 as PN sequence. So in FC2, mark the F0 frequency. In the ninth instant, we are having 0 0 as input binary sequence and 0 0 as FC 0 0 as PN sequence. So in FC0, mark F0 frequency. In the last or 10th instant, we are having 0 1 as input binary sequence and 0 0 as PN sequence. In FC0, mark the F1 frequency. Like this, we are going to represent the graph for frequency versus time for slow FHSS system. Next, the variation of d-hopped frequency with the time. On the x-axis, write only the input binary sequence, okay, and name 0 0 as F0, 0 1 as F1, 1 0 as F2, and 1 1 as F3. On the y-axis, write only the MFSK frequency or MFSK tone in hertz. That is F0. In the level 1, write down F0, 0 0. In the level 2, write down F1, that is 0 1. In the level 3, write down F2, that is 1 0. And in the level 4, you write down F3, that is 1 1. And for the corresponding bit position, mark the corresponding frequency on the y-axis. So this is the variation of d-hopped frequency with time. We'll end this session. Thank you.